end of yesterday. I'm actually going to erase it entirely. Who else do we need to think about if we have this whole addition problem set up, ready to go, but we don't have an answer to it yet? Why do we have to think about the answer? Yeah, we can't solve for x or for y if we don't know what to set them equal to, right? Okay, so we're going to go ahead and set them equal to, well, hold on. When we put these two together, in order to lift, the box, what does the horizontal and vertical components need to equal? Now hold on, does anybody notice the one things I forgot to write in linear combination form? Yeah, we got to get those I and j vectors in there. Let's get our notation proper. Okay. We need to think of what are these equal to. So we're going to go ahead and at the bottom put u plus v. But why am I putting it in this weird tealy color? What else did I put in the weird tealy color? Ah, the 20,240 pounds. Great. Because that is the combined effect. The cranes are lifting it. Now question. The box is pulling down at 20,240. In order to have kinetic energy, in order to be able to lift the crate, you're going to have to exert the exact same amount of force. In order to be able to lift the crate, you're going to have to exert the exact same amount of force. If you can negate the force that is trying to hold the crate on the ground, does that make sense? If you can negate that, if you can match that, then you'll be able to lift it. Now some of you are like, well, you have to be above it. Actually, no. Take physics. But coming back. In order to lift the crate, you have to negate the force that is pulling it to the ground. Does that kind of make sense? Cancel out what's holding it on the ground, or match it, and no problem. You'll be able to lift it just fine. So, the combined effect of the two cranes, it has to be opposite, but equal in magnitude to the crate. Now, hold on. Let me draw the crate's force real quick. Here's the crate's force trying to pull it down. Let's pretend here's the crate, okay? Question. Where is its terminal point? The bottom, right? Where's its initial point? The top. What can I say about the crate's force in components? Is the crate trying to go right or left at all? No. So I could say his components would be 0 horizontally. Why? It's not going horizontal. Where is it going? Vertically down, right? Okay. So what am I going to put as its vertically down component? By how much is it going vertically down? Or by how much force is it pulling vertically down? Exactly. Do you see it? That weight is what's trying to pull it vertically down. Remember, magnitude isn't length per se, it's the force in this problem, or the tension.
But can you use that as like a length? Because it's just kinetic energy pulling it down.
But that's what the tension in the cables need to negate. So they're working together to match that weight. Does that make sense, Luca?
Because we're going to have to have the same force up. Okay, makes sense.
Okay, now hold on. Technically, the crate is trying to pull down, right? So shouldn't I technically put a negative in there? But wait, the crates are pulling what direction? Up. So we're not going to set the crate components equal to the negative 20,240. The crate, or not the crates, the cranes. Oh my goodness, too many CRAs. The cranes are trying to pull up. So I'm saying the combined forces of the cranes have to equal 0I. Why? Well, you don't want them working against each other, like pulling the box back and forth, right? You want them moving up, which they're going to be doing, moving straight up. But what are we going to put for the vertical component?
Plus 20.
Positive 20,240, because the cranes are pulling up to go against or to match the negative force of the crate, which is pulling down. Does that make sense? Okay. That's a mistake I've made many years by accidentally putting the negative there. You got it. Wait, you got it. Mathematically, we got it. Just solve. What? How do we just solve? System of equations. We have two different equations with two different unknowns. We can solve that puppy. Wait, I just see one. No. Why are there two? Doesn't horizontal plus horizontal have to equal horizontal? Ah, and doesn't vertical plus vertical have to equal vertical? So we really do have two equations. You guys ready? This is not for the faint of heart, but we have our calculator, so we don't have to be scared of something like cosine of 155.7, whatever, it's a number, right? Okay, so here we go. Equation number 1. We can say we have x times cosine of 155.7. I'm just going to do it all in red, is that okay? The color coding is over. Plus y cosine of 44.5 has to equal 0. True? Okay. And then don't we also have equation number 2, x sine of 155.7 plus y sine of 44.5 equals, struggle, 20,240. Good? Okay. Why should we not use elimination? If you know what that word means, thank an algebra teacher. Why should we not use elimination?
Wouldn't it just get messy and
Yeah, we have to make the coefficients match. Ugh. Substitution is the only way to go. Once you want to do matrices, and that just makes everything look worse. So, what do you guys want to solve for? X or Y? I don't care. You choose.
Make a little system.
X is equal to, I'm going to use equation number 1. Is that okay? X is equal to, you guys ready?
Yeah.
Don't we just subtract? Why am I not sending you to your calculators and having you plug and chug and get really messy decimals that you're going to round?
Because we can keep the
It's
full.
going to be inaccurate. You guys are going to get all these different answers that are similar but not exact. Oh, come on. Come on. Come back to life. Oh, there. There it is. What are we going to do with this guy? Plug him into the other equation, right? Alright, let's plug him in, plug him in. Now, I'm going to write this a little bit differently. You might want to go ahead and see how I'm writing this. You ready? I'm going to go ahead and put a big old Y with, I have negative cosine of 44.5 times sine of 155.7 all over cosine of 155.7. Do you guys see why I did that?
Because you're gonna have tangent.
Oh, you could do tangent, or you could just say whatever, that whole thing is the coefficient to the y term, right? Isn't y the variable in that piece? Now, I still have more to my equation, true?
Yes.
So plus sine of 44.5 y equals 20,240. What do I do when I have y terms and I'm trying to add them together? We can just combine the like terms, right? Can't we factor out the y? Hold on, help your group. Maybe they don't like this problem and they're falling asleep. Wake them up real quick.
Not really, because you don't have a zero in the other side, so you can factor it out.
Yeah, right?
You would need a 0.
I know.
Uh-oh.
So can't I go ahead and say, now hold on, let's see if this makes sense. Can we do this? Y is equal to 20,240 divided by, now Luca, you notice that on the first term, sine over cosine is the same thing as what?
Tangent of
So we could cheat just a little bit just to make it easier to plug into the calculator. We have negative cosine of 44.5 times tangent of 55.7 plus sine of 44.5. Whew! That's one thing to plug into our calculator and we can get the answer for y. Does that a good thing?
So on the test, or like when we have a quiz, when we have a lot of these,
We have what?
when we have a lot of these on our quiz.
Oh, no, it would be like one.
Okay.
It would be like one. It would be similar to the one that we did in class.
Okay.
Is that cool? Alright, you guys plugging and chugging? Actually, no, I'm gonna show something like that. Thanks. Do you remember how to use a really cool function in your calculator in order to be able to do a nasty fraction exactly without having to stress about parentheses? It's a great shortcut. Alpha y equals, enter, n over d means numerator over denominator, and then we have a nice pretty fraction where we can put in our 20,240, right? All over our negative cosine of 44.5. Times tangent of 55.7. Oh, is it, Caitlin? Is it 155, guys? Struggle. Thanks for catching up. I thought it was a parenthesis. Okay. 155.7. Plus, then we have sine of somebody. Who is it? Sine of 44.5?
Yes.
Woo! Dun.
What a horrible but that's 19. That's 19 comma.
Are you serious?
785.832. Someone back me up. Did you guys get the same answer?
Let's try this again.
Uh-oh.
You got it.
Now hold on, kiddos. I'm not going to take a lot of time on this, but if we have y, what should we be able to get? So here's y. We're going to need to plug and chug to get x.
So we're gonna just use that circle that, right?
Yeah, can't we just plug in the circle thing?
Yeah.
And wait a minute, can't we just steal the numbery thing from that we just got? So we can do our little fraction. Or you better. Negative. Let's go steal that guy. Right? If you guys can't do that, if you have the old calculators with the yellow button, remember you use second, is it second negative, I think?
Oh, I
Go
got that
steal
now.
the answer.
Yeah.
Either way. Times cosine of 44.5. All over cosine of 5.7. Whew. And we should be getting the exact same answers, right guys? 15 comma 484.093. No, 094.
Wait, what's the last?
Is that okay now?
Yeah, I got it.
Okay, so now we have x. Let's just reorient for a second. What are we supposed to be solving for?
I can't remember actually. It's one of those words.
Find the tension.
Good job.
Find the tension. Hold on. We already identified who the tension was, though, right? Who's the tension? Oh, wait. Magnitude of u. Guys, look. Magnitude of u is x. And magnitude of v is y.
Okay.
Oh. So do we have to do anything else? Nope. Dun, 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 dun.
That was a struggle.
When it says, please show using vectors, Karina has a good question. She's like, wait a minute, it says show using vectors. Guess what? Did we do all the vector math?
Yeah.
Perfect. Please show using vectors means
Use the vector.
think about the diagram, and we did, and that's okay. Is that cool? So we set up using vectors, we got them in their components, and we solved. Woo! So we get it. Yes! Let's go do another example. Similar but different. Sean mentioned you guys have a pulley one. Help me out, Sean. That's an odd number, right?
There's an even one that goes with it.
It's similar to this one. Use Calc Chat to help you match up the odd and then maybe go work on the even. Sound good? Okay.
Oh, here we go.
This one is super easy as long as you know the picture. Now hold on. Didn't I say that there's going to be a problem like our examples on the test? One
And
problem.
this might be one.
And this might be one of them.
So I'll highlight it.
Let me have you, if this was the one of them, let me have you highlight something very important to know.
Okay.
Something very important to know that is somewhat against probably your natural logic because all of you but one have not taken physics. Okay?
Highlight the triangle.
Let me go ahead and label some stuff in this triangle. The very cool thing is because I have a broken foot, I'm sitting here and I have a thingy where I can zoom, let's zoom in on this triangle. Okay?
Whoa.
Whoa, it's pixelated, don't think about it. Okay, ready? Let me label some stuff. First of all, question. What is the force that is pulling straight down into the ground?
Gravity.
Check it, check it, check it.
Weight of the-
Check it, check it, check it. Check it, check it, check it. So therefore, gravity, let's just call him G, is that okay?
Oh, no, that's nice.
Gravity is vector, in this case, whatever, dA, AD, dA, right? BA, whatever. Gravity, does it tell us any? No, we'll just say gravity. We can name it either way, right? Gravity or from B to A straight down.
No.
Straight down to the ground, like to the center of the earth. Does that make sense?
Wait, is D the other side?
B is here,
Okay.
D is here, A is here, C is here, E is way out here.
Okay.
Does that make sense? This right here, let's use the pink. This right here is the angle of inclination. This is the angle of inclination. Why inclination? Because it's an inclined slope. But where do you see that angle? And if we had time and if I could draw all sorts of geometric representations, I could show it to you with parallel lines and transversals, yada yada. But long story short, hence why I highlight the triangle. Where else does the angle of inclination go? These two angles are congruent. So whatever the angle of inclination is, we can put him in this triangle. Does that make sense?
So those two triangles
Are
are.
congruent.
Ooh.
How do you know that?
How do you know that?
Because you have a right triangle,
Lots of
you have a
geometry.
15.
Long story
degree
short, can I show it real quick?
Oh yeah.
This slope is no, it's not. Is parallel to this vector. So I can make these two parallel lines. With these two parallel lines, I could have a transversal here. I could have a transversal there. I have this whole deal going. Like we'd have to relate all of this stuff, and it's just gonna take time. But anyway,
They just match.
yeah, they match. Yay! You could think, hold on, some of you are still like, I actually am curious. You could think of this has to form a triangle, and it's going to include this angle, which I could find using that angle, which I could find from 180 using that angle. So look, this angle plus him and 90 has to equal 90. See, they're congruent. See what I mean?
Nice.
The yellow ones are congruent, so therefore the pink ones have to be congruent because both of them form triangles. Okay, that's easier than actually I even thought it was. It's the first time I've ever shown that. Anyway, keep going. Okay, they're congruent. So we can label this dude as the angle of inclination. Okay. Okay. Down here at the bottom. Let's see a different color. This little guy. This is actually going to be from, and this is kind of weird, I know, but this is going to be from the weight of the load of the trailer of whatever is on the incline slope that naturally wants to roll down. Could be of the car in neutral, of the boat on the trailer. Weight, which we could also call vector AC. Technically, weight is trying to have it go down the ramp, but remember, in order to keep it from going down, there has to be an opposite force, or a force in the opposite direction. So this is the force due to weight that the brakes of a car have to exert to hold the car from slipping down a hill, or that the truck with the boat on the trailer has to exert to keep the trailer from falling down the hill, etc. And then last but not least, this one, the third part of our triangle, is going to be what we call the perpendicular force. Yeah, we could say normal force or the perpendicular force. And what do I mean by that? If we were to extend it, this is the force that's perpendicular to or against the ground. That's a better way of saying it. This is the force against the ground, because the boat on the ground does exert a force, but it's going one way because it's against the ground. Gravity is pulling, and to be honest, a different way, and then weight is pulling a different way. Anyway, a lot of physics, don't stress too much about it, but why is this triangle super, super useful? Because look, go to this nasty word problem, okay? A force of 600 pounds. Let's just highlight the important stuff. A force of 600 pounds is required to pull a boat and trailer up a ramp inclined at 15 degrees from the horizontal. Find the combined weight of the boat and the trailer. Okay. A force of 600 pounds is required to pull a boat and trailer up. Okay, hold on. Wait, which of these talks about the force required to pull it up? Do you guys think it's G or W or the perpendicular force? W. That is the force due to the weight, technically due to everybody. But the force that's required to pull up, right? You guys see it pulling up, right? Up the ramp? Okay. So we can say W we're going to find W. Wait a minute. Wait, don't we know W?
dB.
Never mind. Let's label it then. They told us the force required. W has to equal what? Why am I putting double lines? It's the magnitude. 600 pounds. If you want to label it, you can, but units are going to get messy until you take physics and learn what the units are for. Okay, W is 600. What else do we know? Angle of inclination. Who's he?
13.
Who are we trying to find? The combined weight.
We're trying to find EV, right?
So wait, is combined weight gravity? The combined weight. Do you guys remember from physical science what weight is?
The amount of gravity. Oh, that's the force of gravity.
Weight is mass times gravity.
So isn't gravity related to weight? So which vector are we trying to find?
G.
BC.
So let's go ahead, since we just talked about how weight is related to gravity, please zoom back in our picture and change some of those labels. Is that okay? What's going to be a little bit better way of explaining? Maybe we shouldn't use W. Let's just change that. Let's do, can we do F for force? Is that all right? Once we look at our word problem, let's make F for force. Let's do this, G for ground, that's not going to work. S for slope. Let's just keep that one, the force perpendicular to the ramp. We'll just leave that. We could do G, which is due to gravity. We'll just leave it that way. I just wanted to change the W to F. It is, you have to overcome the weight, but that's a little too confusing. Okay. Cool. Oh man, this is awful. We're going to have to think of vector addition and all this craziness. Nope. What do we have to think about? One simple little right triangle.
Trigonometry.
Trigonometry.
Is
It's as easy as
600.
Because we can say with trigonometry, we can say, okay, cool, no big deal. All we have is a triangle, right? I'm going to make it this way just to make it a little easier. We have our F here, we have our G here, and we have our angle of 15 here. Kiddos, if I know F is equal to 600, how do I solve for what side is G? Hypotenuse. And I have an angle, what side is F? Opposite. So what puts together an angle with opposite and hypotenuse? It's as easy as that. The picture is hard. The math is easy. As long as you get the picture.
No, I don't get what they give you that other.
F is the bottom one, which is from A to C.
Wait.
Because that's the force that's required to pull it up the ramp. Does that make sense? Because in the problem, in the problem they say a force is required to pull a boat and trailer up a ramp. So if this boat and trailer are moving, then that means that there are all these forces that are working to have the boat basically fall. But we have this one little force down here that is resulting in this being able to move up the ramp.
So is that the sum of BA and BC?
AC isn't the sum of the two because it's being exerted by an outside force. You could say that BA plus AC ends up with the force against the ground. You could say that's a vector sum, but that's not really one that we think about very often. Like it's not very useful. Did I finish writing it?
Yeah.
Oh no, I didn't.
You see, now why did they give you the triangle EDB? Because
So then we can use it as congruency to find.
the force, yeah.
It was just.
Because this is the incline, and so if you can't connect the incline to this little angle in there, you know what I mean? You'd be like, why on earth is that angle going there? So that's why they gave that one. So it's going to end up equaling multiply up G, divide by, isn't it just 600 over sine of 15? We're just going to leave it there. Let's not worry about decimals. You guys could plug and chug that. I have full confidence. Is that okay? Alright. So the goal, or not the goal, the point of this page, some things in physics you just kind of have to understand how they work, but maybe the math isn't all that hard. Right? Kind of, sort of, maybe.
Yeah.
Okay. So that one, math is easy. Whatchamacallit is hard. Now I want you guys to look at this just for a second.
Look at all this words.
We got this, we got this.
Look at this just for a second.
All this words, man.
Look at this just for a second. Which means we're not going to do the whole thing. Just check it. Question. What's going on?
Alright, we got a plane.
Got a plane. All right.
I feel like
Good start.
we can draw some stuff.
Yeah, I think so too. We have a plane. Okay. Where is he right now?
From going from Miami to Seattle.
Whatever. There's Miami, right? But for sake of illustration, I'm not going to draw the entire United States unless I want to, like, I don't know, do this whole little. There's Texas, and then like there's Florida, and then like there's Maine, and then like Michigan's in there somewhere.
Hey, look at them Great Lakes!
Yay!
Nice.
That should go up
I
that
kind of
high.
like it in
Just-
Washington though.
Just
Michigan
California.
is highly there. That's a little better.
Oh, that's so
Okay.
Just
Hey.
California should go.
So Miami. When I was in Nicaragua, it was actually kind of sad.
This side
They
is
were
awesome.
asking us
This
to
side
draw
is
like the
sad.
United States and all the states. It's hard to tell them because they knew friends. Some of the missionaries down there knew friends. They were from Nicaragua. Knew friends that had gone different places. Like, where's New York? Where's Chicago? I'm like, it was a little sad because they treat the United States better than we did. Anyway, I was challenged. Anyway, so here we go. I'm really practicing. I promise I haven't. Anyway, question. This is what we'll Miami to Seattle, true? Miami, I don't honestly know where he is. He's down close to Cuba though, right?
Yeah.
Somewhere down here. Sure. Seattle, A is up here, somewhere. Someone who actually knows it better than me, don't judge. Okay, so we have a commercial jet flying from Miami to Seattle. The jet's velocity with respect to air is 580 miles per hour. Its bearing is, what makes this problem hard? Okay. It's 332 degrees. The wind. However the flight path is.
How is that 332 degrees?
Hold on. Let's show how. We're going to zoom in on this little part right here. This is the little plane taking off and getting going, okay? So we have a plane. Let's get to a graph. Remember that bearing starts from north, and it turns clockwise.
Oh, it makes sense then.
Oh.
Okay, now we get it.
So now we have 332 degrees. Remember bearing, he starts from north and then he goes clockwise. So we have the plane, here's the plane, headed this way. True?
67.
Yeah.
62 degrees.
332 degrees. And he's heading at 580 miles per hour, right?
Yes.
I'm going to pretend that this is 580 because I say that, or I'm showing that. Let's make that 1 unit, 2 units, 3 units, 4 units, 5 units, and we'll go a little bit more. We'll make it a little longer. Making my units about that long. Just to kind of show that I'm kind of trying to show the 580. So 1, 2, 3, 4, 5. Oh, shouldn't be that long. Can I do 6? Okay, 580. There we go. Who else do we have acting on this plane? Wind. It's blowing from the southwest. From the southwest with a velocity of 60 miles per hour. Now, if they don't tell you an exact angle, then we're going to assume that it's perfectly in the middle of south and west. Does that make sense?
Okay.
From the southwest. Does that mean it's blowing to the southwest, or is it blowing instead from the southwest?
From.
Oh, okay. So it's blowing from the southwest. We'll say that. And it's going to be at 60 miles per hour. Wait, isn't that less than 1 unit? Less than 100? So he's a little baby one.
Nice.
I'll put him as 60.
Okay.
Now, technically, I could have this little guy be up here. That's not working. I could have this little guy be up here, like this way, but if I put it this way, don't we have the vector sum? Because it's head to tail. Okay. So now what are we trying to figure out?
Hey, we did A.
Draw figures. Yay! Write the velocity in component form. Why? Because who wants to deal with it geometrically? Nobody. Right? So we would write velocity in vector form. Now we're going to do everything with bearings, just because that's what we're used to, okay? I don't know if you like bearings, though. Do you like bearings?
Oh, no.
So we're going to do standard form?
I'm indifferent.
What would be the angle in standard form?
Yeah. Straight down.
Be 90 plus 332 taken away from 360, right?
Yeah.
So you go ahead and say 90 plus 28. Double check. Is 332 taken away from 360 is 28. So 90 plus 28 is 118. Does that make sense?
Yeah.
Okay. So we can do him in standard form, so we can go ahead and do for letter B. The velocity of the wind, we'll do the wind vector, is, do you guys remember how to find I and J? One uses cosine,
Okay.
one uses sine. And what else does it use besides sine and cosine? We already used the angle. Magnitude. Isn't that magnitude? So W is, oh wait, does it say wind? Oh, I'm doing the wrong one. Who am I doing? I'm doing the plane. I'm moving down. this is letter C. It's a jet. No, J stands for vector. The plane. Okay. Who would the wind be? What's his magnitude? 60. What's his angle? Well, that's weird. He's not even in standard position. That's okay. Physics says we can make standard position wherever we want him to be. So question, guys, what would his angle be?
45 degrees.
45 degrees. So you can go ahead and do magnitude of him, 60. Sorry, that was magnitude. 60 times cosine of 45 plus 60 sine of 45. What's D say? The speed of the jet with respect to the ground. Does that have to do with his instruments are saying, or what's really going on when you're looking from the ground up to him? What he's trying to do, or what's really going on?
I feel like it's what's really fun.
It's what's really going on. Here's the reason why. What he's trying to do is what his instruments say. But what goes on is, guys, have you ever had a flight where it's the exact same distance one way and then the other, but the time is different? Like it's faster or slower based on wind? If wind is going, if it's a tailwind, if it's against the tail pushing forward, you're going to be going faster because it's going with you and making your speed even quicker, ultimately from the ground. If the wind is going against you, what's happening? It's slowing you down. Now this wind, is it going with the jet? No. Is it going directly against the jet? No, but it's still slowing it down. So when it's saying with respect to the ground, what it's saying is, hey, let's go ahead and just do what is vector W's combined effect with the plane. Oh wait, fixing components, is that a really hard thing to do? Yeah, just add the two together and then we're done, 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 done. Woo! Alright, 6-3, we're done. Woo! We're starting at 6-4.
No.
Come on, we have 2 minutes.
You guys are done.
I refuse.
Come on. We got through the worst section. This one is a little easy formula. Stop complaining. It's a Friday. Let's end with a good, solid push. Here we go.
Okay, so only write down stuff.
With a distance. We have a minimum. Next Friday is a minimum day. Next Friday is your test. Let's go.
Wait, next Thursday?
But it doesn't matter, we still have this class.
The calendar's been up for like a month. Wait a minute. I see a times. Do you see a times? I see a times. I'm trying to always focus on what's important. Times. What's important right now in this very moment? Exactly. Multiplication of 2 vectors. Oh my goodness, it doesn't work like we're used to. Scalar, no big deal. Bring the constant in. Vector addition, no big deal. Add the like terms. Vector multiplication. It's a little different. But wait. Vector multiplication is called the dot product. Otherwise, if we call it vector multiplication, you'll try to actually do something with multiplying. I don't really know. But, kiddos, look at the formula. To do the dot product, which is one vector. Uh-oh, are you guys writing your thing?
Yeah, I was gonna ask right now. Do you want the U with the yep?
Of course she wants that.
Of course I do. Vector U times vector V is equal to. Wait, how do they do it? Guys, it's so easy. Look. We take the horizontal times the horizontal plus the vertical times the vertical. That's it.
Hey.
And it's gonna It's gonna equal. Wait. You guys were complaining. Keep you 30 more seconds. It's gonna equal one scalar number. What does that mean? Good thing we're not in physics, or we'd actually have to learn. Bye. See you guys later.
Oh,
Do 6-3 to the best of your ability. We'll see what's most important for the test on Monday.